Okay, let's look at questions 7 through 15. It says in the figure at the right, EF is parallel to BH. So let's kind of just highlight those real quick. EF is parallel to BH. So these are parallel. Okay. So I'm going to leave that as an aside because I want to take note of something else going on in this photo. You'll see, if you ignore E, F, and BH, you'll see that these, they don't say they're parallel, do they? We don't know that line EB here. Oh, there we go. And CH, we don't know just yet that they're parallel. They don't state that they are, and they don't give us the arrows to indicate it. But what you'll notice is we have a transversal right here. We'll call it AD. And you'll see that they create these right angles. So this is 90 degrees and this is 90 degrees. Now, what's the relationship between those two angles? Are they alternate exterior, alternate interior, same side exterior, same side interior? Are they corresponding? These are corresponding. We know they're corresponding, and since they're corresponding, we know that these two lines must be parallel. This kind of leads us into what you'll learn later, the converse of corresponding angles theorem. But the idea here is we know these must be parallel, the two purple lines, because their corresponding angles are congruent. So that's just a little side note I wanted to put there. Maybe we can put this back. Okay. So EF intersects AD at C. Determine whether this is true or false. Okay, EF is this orange line, and is it intersecting AD at point C? We can say yes. This is something we can assume. We can assume betweenness of points. So we can assume that it intersects AD at point C. HC is perpendicular to DB. Let's check this out. HC is this purple line here. And we want to know if it's perpendicular to DB. DB is this green line here. And quite clearly we see that it creates a 90-degree angle. And since it creates a 90-degree angle, we know by definition of perpendicular lines that, yes indeed, these are perpendicular. Is EB parallel to CH? EB and CH. Yeah, those are those purple lines. And we've already spoken about this. We know that they are parallel because of corresponding angles theorem. Specifically, the converse of corresponding angles theorem. BG is perpendicular to CH. BG is this orange line right here. And we want to know if it's perpendicular to CH. So CH, again, is this purple line. And there is no indicator that it's a right angle, and there's no way we can use the current transversals to say that they're perpendicular. In fact, I think we could prove that they're not perpendicular. So this is kind of a dead giveaway. No. Is CF parallel to BE? CF is this orange line here. And we want to know if it's parallel to BE. BE is this purple line right here. Are they parallel? No, they intersect right here at point E. So no, they're not parallel. Okay, angle EBC is a right angle. Angle EBC, is that a right angle? Quite clearly we see, yes, it's a right angle. Angle DCE is a right angle. Angle DCE, is this a right angle? Well, we know that there's a right angle in it, but there's also this angle remaining, so it has to be greater than 90 degrees, making it not a right angle. So no. The measure of angle HCB is 90 degrees. Now I'll leave these for you guys. These are good ones to leave remaining for you. Let's go through just a couple of these. Here we go, 18, let's look at this. So they're saying that this angle here is 5x plus 90 degrees. And this one right here is 14x plus 9 degrees. Well, what's the relationship between these two angles? One thing to note is we know that L and M are parallel. So these are parallel, these two lines. So that must mean that these two angles are congruent since they're corresponding. And since they're congruent, we can write the following equation. We should all know how to solve this by now. Get x equals 9. Let's do another one of these. This is a good one. This angle here is 9x minus 5. And this angle right here is 7x plus 13, or plus 3. That's this angle here. Now, I know the relationship between these two angles, we don't really know what that is. One's on the outside and on the alternate side, one's on the interior, alternate to that other angle. But what I can say is by vertical angles, this angle right here must also be 7x plus 3. And in which case we can look at the relationship of these two angles. What are they? They're on the same side of the transversal, and they're on the inside of the parallel lines. Therefore, they must be same side interior, which means they are supplementary, which means we can write the following equation. When solving, we combine like terms. Plus 2. So that would be 10 and some change. Let's see. 16 times 10 is 160, which means we have 22 remaining. 6 goes into 22, not equally, so for now I'm going to write x equals 182 divided by 16, which, let's see what that reduces to, 91/8. Now this is kind of an interesting answer, so I'm just going to real quick double check I wrote these right. 9x minus 5, 7x plus 3. 16x, it's -2. Add 2. Okay, it appears to be good. So this is what we get. We can say it's approximately, what did we get? 11.3. Okay, and that's what those should look like.